Welcome friends, welcome to the lecture series of analog electronics. So today we are going to learn about the controllers. So there were four types of different analog controllers that we have seen in the previous lecture. So we will get some brief idea about these controllers. So first of all, if we talk about the proportional controller, then you can see that proportional controller is somewhat like this way. It can be described in circuit diagram like this way. So let's understand. First of all, the main point which we need to consider, that is for the output power. The output power is directly proportional to the control error. Means whatever the error will be generated through this feedback will be directly proportional to for the output. So that is the main concept and noticed thing for this P controller, that output power is directly proportional to the control error, right? After that, if we further discuss about the gain, the proportion gain, higher the proportion gain will be result into the lesser output power at same control error. Whatever the error is generated due to this particular input provided at this terminals will be directly proportional to the gain, but in the inverse form. Let's say that the proportion gain is high, then the output power will be low, and as the proportion gain is low, the output power will be more at same control error. Okay, and the output power is more oftenly described in this way, that is our VO is equals to minus RF by RI multiplied by VI. So here you can see this is our gain and this one will be the input. So this way it can be described. Now further, if we want to modify the output values, right, then it can be modified by varying this RF and RI, the value of feedback resistance and the value of this Ri resistance, right? So this way it can be modified and you can change the output value of this particular P controller. Let's get into the advantages, that the P controller has a fast response comparatively with the other particular controllers, right? They have a fast response, and the response which will be described as that if you change a particular input, then immediately it will be reflected at the output terminals. Here you can see that output power is directly proportional to the error input signal. So in this way it will be a lesser speed response, right? So in this condition the speed response will be higher, and if we change in output, then it will take as soon as an error is produced. As the error is produced, and same way the output will be produced at the output terminals. So this way it can be described. After that, I controller, we will see, that is our integral controller, and this one was our P controller, right? So the I controller is nothing but the output power is directly proportional to the integral of error input signal. Whatever the error is generated in this particular circuit diagram will be integrated, and then after the whatever the value achieved will be directly proportional to this output power. So this way I controller can be designed, and the equation for the I controller will be like this way, that is VO is equals to minus 1 by RC integral VI dt plus K. In this condition what is happening, that gradual charging of the capacitor is being taken place, and whatever the output voltage will be changes will be gradually changing. Okay, so it will not change instant, like just a peak at some value and after that it will be decreasing. No, it's not like that. It will be changing gradually. Means it will be having some increase in the output value, right, at a certain particular time, and gradually it will be start increasing. So let's get into the advantages of this particular integral control. First of all, they are having slow speed response. Slow speed response will be there into the eye controller, and that's why the system will not oscillate. Okay, so that is the main thing. And value of parameter being controlled without any fluctuations. There isn't any kind of fluctuations due to this controlled output, right? So that is the one thing. And the disadvantage of this controller will be the slow speed of response. Okay, so this way you can describe this eye controller. Let's get into the PI controller now. Up till this we have discussed about the P and I controller. Now in this PI controller you can see both proportional and integral actions together in this controller. Okay, so there will be one resistance over here, one feedback resistance with capacitor series connected, and the output is taking at this VO terminal. Here you can see P plus I is the practical inverting integrator circuit, right? Okay, so in this circuit RF and R1 provide the proportional action. Okay, here you can notice this thing, that RF and R1 providing the proportional action, and C provides integral action. Okay, so this way. And if you want to notice the proportional gain, then it could be described in this way, minus RF by R1, and the integral gain can be described as R1 into C. So let's check that whatever the advantages of this PI controller, the first advantage of this PI controller will be the zero control error. Okay, so it will be generating zero control error. So it is a beneficial thing. Insensitive, right, to interference of the measurement channel. Whatever the measuring channel is there, or we can say the feedback conditions is applied, they were quite insensitive due to the interference. That's why the output will not be much varied due to the variations. Okay, so that is the one thing. After that, if you can check the disadvantages can be described in this way, that P plus I has its slow speed response. See, slow speed response is continuous. As we have checked for the P controller, it will be particular values. It will be having a fast response, right? So this way. Now this, after this learning all these three controllers, right? So after this all three controllers, now we are checking a particular condition of this all three together, and that kind of controller is called as the PID controller. So let's understand that how a PID controller will work. So first of all, the PID controller will be having the output power directly proportional, integral and differential. On all these three actions will be directly proportional to the output power. Now let's see how it will be affecting this. Then first, proportional coefficient will be greater. If the proportion coefficient is greater, then the output power will be less at same control error. Okay. After that, if we check differentiation coefficient, if it is higher, then the response of the system to the disturbance will be also higher. And if the integration coefficient is higher, then the slower accumulated integration coefficient. We will be having slower accumulated integration coefficient. So in this condition, due to this capacitor, it is happening, right? So whenever the circuit introduces one capacitor in it, the response will be a bit slower, right? So here it is the circuit. Like this way, a circuit can be formed for the PID controller. There will be two resistance and one resistance with the capacitor. After that, one resistor and capacitor, and the op amp is attached. Now, if we want to define the proportional gain, then it can be described in this minus RF by R1. Integral time constant can be described as this R1 and C1. So both these values will be differing the time constant value of this integral time constant, and differentiation time constant will be described as feedback resistance and capacitor values. Okay, so this is the basic process, and for the process of proper adjustment of the three parameters that are proportional gain, integrator time constant and differentiator time constant is known as controller optimization. Okay, so mind well one thing, that if they can ask you that what is the controller optimization in this PID controller, then it can be described in this way. Okay, so this optimization is quite useful for the PID controller. Let's check how it is useful. First we will check the advantages, and this advantages we will be having this term, and we will get some idea about this controller optimization. So first of all, the response will be faster of this PID controller, right? No overshoot. Now overshoot means what? They are at a particular range. Okay, so the range, below the range or over the range will be defined as, if it is over the range, then it will be considered as overshoots, and if it is below the range, then it is considered as the undershoots. So if properly optimized, then it is not possible that it will be overshooting or undershooting. Okay, so optimization is quite important in these conditions. So what we need to take care of, we need to take care of this all parameters whichever are in the circuits. So by optimizing this thing, we can ensure the stable operations. So main purpose is our stable operating conditions, right? So that can be achieved by this optimization. So after that, some disadvantages is also there. Let's see, controller optimization needs to be done as per the system parameters. As you can see, the system is not persisting more than a particular range, and if you keep on increasing the values, then it should not be allowed, or we can say the system will not persist for this optimization. See, so you need to take care of these parameters, but in a particular range or whatever the circuit is designed to perform for. So that you need to take care of. And the second thing, that is optimization, is a little tricky, right? If you check that RC circuit is making a time constant circuit, or maybe it is like that, it will be oscillating or non-oscillating. So if it will be oscillating, then it will be of no use for us, as we need to filter it out, right? So these are the problems associated with this PID controller. And if you further check for the applications, the main applications of this PID controller are temperature control, pressure control, and other industrial systems. So temperature control is quite useful, pressure control is quite useful, and many other industrial applications are having this PID controller built in for the particular systems. Okay, so this way a controller can be described, and that's how a PID controller will work. If you gain some of the knowledge from this video, then you should definitely like and share my video, and to watch more this kind of videos, do subscribe to my channel. Thank you for watching the video.